Hello, this is the second video on volumes of revolution. Today, we're looking at volumes of revolution about the y-axis. Now, hopefully you saw my previous video on volumes of revolution, which was volumes of revolution about the x-axis. But in case you didn't, quick reminder, or in case you just want a reminder, it is this idea where you have an area of a 2D region that usually would be formed by integrating the equation of the curve that you have at the top with respect to x. And what we're going to do is we're going to attach that region to the x-axis at the bottom, rotate that region 360 degrees about the x-axis, and then as that region is rotating about the axis, whatever space it travels through, we will then fill with some volume to form a 3D shape. Therefore, if you rotate a rectangle, you'll just form a cylinder, is what we said in the previous video. But that's volumes of revolution about the x-axis. What about volumes of revolution about the y-axis? Well, it's pretty much a very similar idea, but it's just that the y-axis will now hold the role that the x-axis had before, but there also are some changes to how we do the calculation, more importantly, because of course volumes of revolution is then the idea of then actually calculating the volume of that shape you've created. So what we're going to do is we're going to take our 2D region and instead this time we're going to attach it to the y-axis. And then we're going to rotate it 360 degrees about the y-axis. Again, whatever space this 2D region travels through, we're then going to fill to form a 3D shape. So if you were doing that here, again, because it was only a rectangle, it forms a cylinder again, but a different cylinder to the style one we would have had before, just because the direction we're rotating it in ends up creating a different shape. So there you go. That is what we would get here. But that's what's going on. How do we do it? Well, here's the thing. If you want to rotate or find the volume of a solid, I should say, formed when rotating a region 360 degrees about the y-axis, it's given by the formula pi lots of the integral from a to b of x squared dy. Now, things to be aware of. For a start, it's not in the form booklet, just like the other volumes of revolution formula you need to know. And that's therefore one you're going to need to remember. But then also there are some other details that make this a bit weird and different to what we were doing before. The first of which is we've got an x squared there. And again, just like the y was a placeholder in the volumes of revolution about the x-axis method, the x is also a placeholder in the volumes of revolution about the y-axis method. But what it needs to be replaced with is the equation of the curve you're dealing with. However, you need to make sure your equation of your curve is in the form x equals. If it's already given to you in that form, brilliant, you can just substitute it straight in. If it isn't, you need to rearrange the equation of the curve first. And then the other aspect is, because we're integrating y's, and you can tell that because of the fact we've got the dy written there, that means the limits of the integral have to be y values. Okay, so that's also very important. The other thing to point out is because we're integrating y's, it actually means the region that we're using to rotate about the y-axis is maybe different to what we were dealing with before. Because what we were dealing with before with volumes of revolution about the x-axis is we were integrating x's, and so therefore that meant the region that we were rotating was the region between the curve and the x-axis. But we are integrating y's, and if you integrate y's, it will find the area between the curve and the y-axis instead. So that is the region that we would be rotating if we were integrating that curve as part of volumes of revolution about the y-axis. So in other words, integrating the y's. Cool. So let's put that all together in an example. I have got a bit of a wordy question for this stuff, partly because in the last video we didn't deal with that, but I did point out this is one of their favorite topics to convert into a mathematical modeling sort of question, just because ultimately it's very easy to apply this stuff to the real world, because guess what? We live in a 3D world, so there's loads of 3D stuff around us everywhere, and maybe we want to find the volume of it for some reason. So there you go. So we've been given an equation of a curve. They're telling us the inside of the bowl is modeled by the curve, and it's being rotated 360 degrees about the y-axis. Now straight away that makes sense, because if you sort of view this curve, as the cross-section of a bowl. If you rotate it about the y-axis, that means the full cross-section is then looking like this from the side, which makes sense because that looks kind of bowl-shaped. And then they're telling us some information about how much the units on the graph relate to reality. That's not going to be important for most of the question, but that will be important for the final answer. And they want us to determine how much volume the bowl contains inside of it, effectively. Which is then good because they told us to rotate about the y-axis, in other words, do volumes of revolution about the y-axis, which all makes sense because if we're rotating about the y-axis, that means we're going to be integrating y's, which means we're going to be finding the area, we're going to be using the area between the curve and the y-axis as part of that process to create the volume, which is good because that would be, therefore, the volume inside the bowl. So it's all linking up and all making sense with what we're trying to find. However, because we're trying to find volumes of revolution about the y-axis, there's a few details we need to be aware of, as we pointed out before. The first of which is we know in the formula it's pi lots of the integral of x squared. So therefore, we need to find the equation in the form, well, x squared if that was possible, but in reality just x equals, so we can sub into the formula with x squared. So we need to start off by rearranging the equation to make it x equals. So first thing you can do is divide both sides by 13 over 1024, which gets you that. And then, of course, all you got to do is cube root both sides to get what y is. Now, that does mean, in this case, we're going to have a pretty grim-looking coefficient, which does actually end up happening with a lot of these wordy mathematical model-based questions, because in the real world, numbers are often horrible, unfortunately. So they're just mimicking that. It does make it a bit of a pain to deal with, but it's just a case of just, dealing with it. Your calculator can deal with the horrible numbers side of things. One thing we do have to realize, of course, is index laws. First of all, that cube root can be written as a power of a third, and that also we can then separately apply the cube root to that number and the y. So basically we got the cube root of 1024 over 13, lots of y to the power of a third. The other thing we need to be aware of before we actually launch into the volumes of revolution is the limits. The limits need to be y values. Now they have given us x values as the limits. We know the curve is starting at x equals 0 and finishing at x equals 8, but we need what this y value is here and this y value here is. Now the one at the bottom is obvious because it's starting at the origin. You can check by plugging into the curve, plug in x equals 0, you get y equals 0, so that's an easy one. But we also need to know this y value at the top, and you notice that's the point where x is equal to 8. So therefore we need to find that y value, and that y value will therefore be 13 over 1024, lots of 8 cubed, which looks like it's going to be a really horrible number, but if I type that into the calculator, you will get 13 over 2, which is 6.5. 13 over 2 or 6.5, doesn't matter, whatever you prefer to write. So therefore, our limits are going to be from 0 to 6.5. Cool. Right then, we now have all the things we need. We can now get on with actually doing the integration to find the volumes of revolution. So, a reminder, it's the pi lots of the integral, as we said, from 0 to 6.5 of our x equation, which was a horrible looking equation, 1024 over 13 cube rooted as the coefficient, and y to the power of 1/3. And then that's what x is, but remember, we got to square that, and we are integrating y's. So we've just got to go ahead and do that. So the first thing you've got to do is square that before we're even able to do the integration. And that means we've got to square the cube root of 1024 over 13, which you could decide to write as 1024 over 13 to the power of 2/3 if you like. And then we've got y to the power of 2/3. Interestingly, you can actually do sort of surd form, if you will, with cube roots. If you were to do 1024 over 13 to the power of 2/3, that would end up simplifying to 64 over 13, lots of the cube root of 52, in case you're interested. But it doesn't really matter for our purposes. I'm going to leave it like this. And then we just got to integrate. So we're going to add 1 to the power, which means we're going to end up with y to the power of 5 over 3. And then we're going to divide by 5 over 3, which means you're obviously going to have 3/5 of the cube. Well, 1024 to the power of 2/3, I should say, to be precise. As I said, not a very nice coefficient, but it doesn't matter. The calculator can deal with that. Remember the pi at the front. So easy for students to forget that pi. Consistently writing it. Don't be lazy and go, oh, remember at the end, because you won't. You'll forget it. So write it every single time. And then the limit's 6.5 and 0. All you got to do is then plug those limits in. Of course, the limit plugging 0 in will get nothing. And then you can find what that is. Now, if you write that in exact form, that comes to a final answer of 1,248 over 5 lots of pi. However, this was a wordy question with a wordy scenario, so there are a few things you want to do with the end of these sort of questions. A, if they give units, got to make sure your answers in terms of those units. So we've got to be, well, as the units on the graph are centimeters, the volume will be centimeters cubed. And then the other aspect is, generally for wordy questions, sure, good idea to write your answer in exact form first, just in case that is what the mark scheme has. But I generally like to write my answer as a decimal for any wordy question, because in the real world, generally that's how other people like answers to be presented. So writing that in the format they want. Also worth pointing out, one last thing, do pay attention to the way they want the answer to be written. They did say they want it to one decimal place, so that was the other clue anyway. So therefore, we're typing that to calculator, we get 784.1 and therefore centimeters cubed. There you go, to one decimal place. There you go, we've done it. Nice, that's volumes of revolution about the y-axis. Ultimately, the main thing that decides the difficulty of these questions is just the difficulty of the integral, which is decided by, you know, how difficult the integration is based on your maths A-level knowledge. So ultimately, the volumes of revolution doesn't add that much extra difficulty to the question in and of itself, as long as you're aware of these details. Like if you're doing it about the y-axis, it's got to have the equation as x equals. If it's not, rearrange it, and then the limits have to be y values. Cool. Hopefully you found that useful and interesting. I'll see you in a future video, maybe on volumes of revolution, maybe on a different topic. Who knows? Goodbye.